All right, so all of our problems on this particular page deal with sine and cosine. So we are going to assume that we have an interval from 0 to 2 pi. If you were dealing with tangent or cotangent, you've got to change that interval to be 0 to pi. And you're going to have that in your homework. So be careful with that. And then, of course, if you use cosecant, secant, or cotangent, at the very end you want to swap those out for their inverses. But you'll still deal with them until the end. All right, so for this one, example 5, we've got sine squared x and regular sine x. So when you've got anything that's to a power other than 1, you want to make sure that everything's on one side or the other. In other words, you want 0 to be on one side. And you want your squared term, your highest, or whatever your highest degree term happens to be. In this case, it's the squared term. You want that to be positive. So if it's not positive, move everything over to the other side. Or multiply or divide everything by -1. You'll accomplish the same thing. So instead of sine of x, I'm going to let x be sine of x. So I'm going to replace this with 2x squared instead of sine squared, minus x minus 1 equals 0. We'll put the sine of x back in once we solve for x. So here we're just doing basic factoring. So you're going to take your bookends, 2 times -1. You get a product of -2. Because your product is negative, we're going to subtract the factors of 2. I'm looking for a middle term that's -1. There's only one set of factors for 2, 1 and 2. Fortunately, they do subtract, give us 1. We want -1. So what are the signs over here? Yeah, +1 and -2. Because I have a coefficient for my squared term, we need to use our box method to see what or whatever method you choose. I'm going to go with the box method. So I'm going to add an x to my middle terms. So here's our box. So our bookends go in this diagonal, so 2x squared and -1. And then my middle terms, and it doesn't matter what order, of -x and -2x go here. And then these middle terms, they are the ones that carry the sign for the binomials. So you're going to find your GCF going up and your GCF going to the left. So for this column, what do they have in common? Just an x. So we're going to put an x up here. And for this column, ignore the sign. What do they have in common? Nothing. So that means I have 1 in common, right? Because this box is negative, we're going to put a -1 there. So then go in the first row. What do they have in common? A 2x. And ignore the sign. What does this row have in common? Again, nothing. But because that box there is negative, that becomes a -1. So our binomials would be 2x minus 1 and x minus 1 equals 0. So I'm going to swap out the x for sine of x. So I really have 2 sine of x minus 1 equals 0, and sine of x minus 1 equals 0. So then solve. Here I'm going to add 1 and divide by 2. So I get sine of x is equal to 1 over 2. Here I'm just going to add 1. Sine of x is equal to 1. So on this one, we're going to look at our coordinate grid. We're looking at where sine is positive. So all students take calculus. Sine is positive in quadrants 1 and 2. So my reference triangles go in 1 and 2. My x is here. Sine is whatever what? Opposite of our hypotenuse. So I have, opposite would be +1, and my hypotenuse is 2. It doesn't matter what the third side is, because all I'm interested in is what is across from x. So x is across from 1, so that means that x is equal to what? 30 degrees, which is our reference angle. It just so happens that our reference angle is in quadrant 1. Our radian measure for that is pi over 6. So that's one of our answers. So x is equal to pi over 6. And then over here, because it's over 6, I want to take pi and multiply it by 6. So I get 6 pi over 6. We want to go one less than that. So what do we have? 5 pi over 6. So there's two of our answers. Then here we want to find out where is sine 1. Remember, sine, whenever you have 0 or 1 or negative 1, it's got to be one of your ordered pairs. So my ordered pairs here would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And this is 0, pi over 2, pi, and 3 pi over 2. We don't care about 2 pi because our answer wouldn't include 2 pi anyway. So sine is it x or y? X or y? You should know that by now, isn't it y? So sine is y, so wherever y is 1. Here's where y is 1 here. That's negative 1. There's only one answer, isn't there? So we end up with x equaling for this one, pi over 2. Then look at example 6. What's different about example 5 and 6? Yeah, we have different trig functions. We have a sine squared and a cosine. So we can't do in this one what we did in example 5. So this is very similar to example 4 on the worksheet that I gave you on Friday. So we need, anytime you have something squared, sine squared, cosine squared, tangent squared, you can swap those out for their Pythagorean identities. So that's what we're going to do first. I'm going to take 2, swap out sine squared, and be careful that you swap out correctly. Sine squared is equal to 1 minus cosine squared of x plus 3 cosine of x minus 3 equals 0. So now we're going to have all cosines, which is good. I'm going to distribute my 2 into parentheses. So I get 2 minus 2 cosine squared x plus 3 cosine of x minus 3 equals 0. And then I have some like terms to combine. And I want to write it in descending order. Highest degree term is the cosine squared, so minus 2 cosine squared x plus the 3 cosine of x, and then positive 2 and negative 3 combine to give me negative 1. Is there an issue? What's the issue? Yeah, we need our squared term to be positive. We don't have to, it just makes life a whole lot easier. So I'm going to divide or multiply, it won't matter which. This whole side by negative 1 and that whole side by negative 1. Moving everything over to the right side would accomplish the same thing. So I get 2 cosine squared x minus 3 cosine of x plus 1 equals 0. I'm going to take away cosine of x, replace it with just x. So I'm factoring 2x squared minus 3x plus 1 equals 0. So using our box method, my bookends, which is 2 times 1. I get a positive product of 2, so it means I'm adding my factors of 2. I'm looking for a middle term of negative 3. So there's only one set of factors for 2. Fortunately, they add to give me 3. If I want that 3 to be negative, don't both of those have to be negative. Make sure you attach your variable to those middle terms, and then we're going to use our box. Our bookends go in this diagonal, so we've got 2x squared and 1. And then our middle terms go on the other diagonal, doesn't matter what order, negative x, negative 2x. And those middle term boxes carry the sign, no matter what. And so we are going to find the GCF up and to the left. So we get, first column, what do they have in common? X. second column, a 1, but because that box is negative, we're putting a -1. They don't have a -1 in common, but remember, it's the box that carries the sign. Then our first row across, what do they have in common? 2x. And then this one here, a -1 because that box carries a sign. And so we have 2x minus 1, x minus 1 equals 0. So we're going to replace our x with cosine of x and set each of those equal to 0. So we have 2 cosine of x minus 1 equals 0. We have cosine of x minus 1 equals 0. So you go and solve from that. I will probably bring it up here, but then you can look and ask questions as you go on. Any questions about how I got those? Yes. You can speak louder because I can't hear what you're saying.
In the beginning, you said squared x, is equal to
In the very beginning? Like right up here? So I replace that sign squared with this Pythagorean identity. How do I go from here to here? Because your normal Pythagorean identity is sine squared x plus cosine squared x equals 1, right? And if I want to replace sine squared, here's sine squared, I have to get rid of the cosine squared by subtracting it over here, so I get 1 minus cosine squared. Does that make sense? That's what I got now. Questions about that before I finish the last one? Okay, so keep going on this one. So for the second binomial cosine x minus 1, you should get x is equal to 0. Why? Because when you solve, you get cosine of x is 1. Cosine is the x value of the ordered pair. Nobody should have their cell phones out right now. This is math time. You're focusing on math. You're the second one that had it out. Just saying. So the only ordered pair that has an x value of 1 is at 0. We are not counting 2 pi at that same place because our interval goes up to 2 pi but doesn't include 2 pi. So you only have one answer of 0. Okay? All right, so then look to example 7. 6 and 7 appear to be similar, but they are different. How is example 7 different from example 6? Say that again. One of them has one side set equal to 0, one of them doesn't. That's true. What else is different about them? I don't have any squared terms in this example, right? So the only way that, and I've got a cosine and a sine, just like example 6, but I have no way of converting them to the same trig function because they're not Pythagorean identities, because I don't have anything squared. The only thing I can substitute cosine for is its inverse, right, 1 over secant, or sine, 1 over cosecant. That's not going to get me the same trig function. So in this case, when you don't have something squared, but you have two different trig expressions, you are going to square both sides. You want to make sure that you have one of the different trig functions on the left and one on the right. So if this had been set equal to 0, you would want to change it so you have one trig function on the left side, one trig function on the right side, preferably where they'll be positive, if you can at least, at any way possible, make them positive. So square both sides. And you'll see why we're going to do that. So I'm going to square this side, and I'm going to square this side. This side squared, a little bit more complicated. This side squared is not cosine squared plus 1. It has a middle term, so square it correctly by FOILing or double distributing. The right side is easy to square because it's just sine squared of x. Here, when I square it, cosine times cosine, cosine squared x, cosine times 1 plus cosine of x, 1 times cosine, cosine of x, 1 times 1, 1 equals sine squared x. Now I have squared things in there, don't I? So I can either make them all sine or all cosine. Which would be easier? Make them all cosine, because if I try to switch that into sine, which I could, do I have any way to switch these into sine? No. So this is the one that I want to swap out, this one right here. So I'm going to replace that one with 1 minus the cosine squared of x from its Pythagorean identity. Then I also have like terms over here that I can combine. I've got 2 cosines of x's. So they combine as 2 cosine of x. So I have cosine squared x plus 2 cosine of x plus 1. And now I have a problem that's almost like example 5. But what do I have to do? One side needs to be 0, right? So we are going to move everything over here from the right to the left because I want my squared term to be positive. So I'm going to subtract 1 with its like term. I'm going to add a cosine squared of x and add a cosine squared of x. So those cancel. I have 2 cosine squared x's. The squared does not change to a 4th because when we add like terms, we only add their coefficients. Then we have plus 2 cosine of x. And then don't those cancel out? Equals 0. So this is actually an easier factoring problem. I don't have to use the box method. I've got 2 terms. Don't they both have a 2 and a cosine in common? So I'm going to factor a 2 cosine of x out in front of parentheses. If I divide this by a 2 cosine of x, the 2's cancel. One of the cosines cancel. I'm left with a cosine. If I divide these two, I'm taking something and dividing it by itself, I get a plus 1 equals 0. We got now 2 different factors, so each of those equal to 0. So 2 cosine of x is equal to 0. Cosine of x plus 1 equals 0. Solve for cosine of x. Here you're going to divide by 2. That just means that I get 0. I divide both sides by 2. 0 divided by 2 is 0. Here I'm going to subtract 1. So cosine of x is equal to negative 1. So both of those are dealing with 0 and negative 1, which screams out to you what? Ordered pairs. So I'm going to look at my ordered pairs, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So here I have 0, pi over 2, pi, and 3 pi over 2. cosine of x, is it the x value or the y value? X value. So for this one, I want to know, where is the x value 0? Isn't that in 2 places? So for this one, I've got x is equal to pi over 2 and 3 pi over 2. For this one, I want to know, where is the x value negative 1? There's only one spot where it's negative 1, and that's at pi. So this one has 3 answers. So for your note purposes, you might say this answer came from that one, and these 2 came from this one. Questions on that? Being able to identify what you have, what problem is that similar to that you've done in the past, and how did you approach that problem? Because we approached each of those 3 differently. The first one, we just plain factored. The second one, we had to do a little bit of substitution before we could just do plain factoring. The third one, we had to square both sides, get one side set equal to 0, and then we might have had to factor, just plain factoring, but the ones here canceled, so it left us with a much easier factoring, where we didn't have to use that box method. This last one, you're going to use your calculator. So break out your calculator. And we're going to put this into y sub 1. So you're going to go into here, go to your y equals. None of your plots up here should be lit up. If any of your plots are lit up, you need to go into stat plot, which is second y equals, and turn those off so they're not highlighted. If they're highlighted, you're going to end up with a box and whisker up there or a bar graph or something. You don't want that. In addition, make sure, so I've plugged it into here already. When you do cubed, you're going to do, notice what I did. I did sine of x, I ended my parentheses at x, and I raised that to the 3rd power. That's not normally how we write it, but that's how you have to put it into your calculator. Because you cannot put a cube right here in between the x and the sine. Your calculator won't let you do that. So you have to put it out here. And then this is just your plain minus sine of x, and then you have minus 1. Now a lot of if you go to plot it, you have an issue. Well, let me mess up my calculator, first of all. So many of you, if you went to try to graph it, it looked like this if you have your standard viewing window, right? So go to, and that's wrong, by the way. That's not how it's supposed to graph. So go to your window. So hit window. Make sure it's your standard viewing window of negative 10, 10, 1, negative 10, 10, 1. So that's number 1. Number 2, you want to make sure that you are in, so your calculator must be in Radian mode. So if I hit Radian mode, so I'm going to go to mode, and I'm going to click on Radian, hit enter. Now if I hit graph, oh darn it, it's doing it correctly. Well, some of you, hang on, let's see if I can make it look funky. No, maybe that one's not correct. Is that what, that's not correct. I'm pretty sure that's not correct. Yeah, well, it might be, but that's not correct. Hit instead, I don't think it's correct. I did 2 of these already today. Hit instead zoom, and then trig. Does it look different? Oh my, yes. What happened? It stopped. Seriously, that was too much for my calculator. Hang on. Uh-oh. My calculator's now very unhappy with me. So, zoom, trig. Ah, there it goes. I don't know why it was unhappy, but that's what it should look like. So the other thing you need to write in here is remember, once you do zoom trig, it tends to stay in zoom trig. But you have to keep tracking it. So then you need to hit zoom trig. What that does is it just zooms it in a little bit so you can actually see the curve better. The radian measure allows us to see our interval that we're looking at from 0 to 2 pi. When we solve these equations with trig functions, we're really finding the zeros. We're finding where that graph is crossing the x-axis between 0 and 2 pi. So this one, if we were to solve this particular equation here, we could do it by hand, but we're going to use our calculator this time. And I want to find out where it's crossing here on the x-axis, but I've got to figure out what my interval length is. So if you take your trace feature, now notice that x says 0 there. And then when I go 1 off of there on my trace feature, x says 0.13. It's a huge clue to you that you're in degrees, so I'm going to switch my mode back to degrees just for chuckle's sake. Okay, well first of all it looks like that. Which is really wrong, right? So then what if I hit zoom trig? Oh, I got upset with me now. Why is it getting so excited? There it goes. So my calculator is currently in degrees. Okay, it looks the same as it did before, right? But this time if I hit trace, I'm at 0, but look what happens when I'm just 1 off. What's the x value? 7.5. I'm already out of the x value for my interval. My interval goes from 0 to 2 pi. What's 2 pi in decimal form? 6.28. I'm already outside of that. Do you see where I'm at? So that's a huge clue to you that you're in degrees. So I'm going to go back to radians. Oh. See, this is what some of yours will look like. That's what I was trying to get it to look like. It looks like a heartbeat monitor, doesn't it? Yeah. Let it finish its thing. Alright, so go to zoom trig. So your calculator can do a whole bunch of weird things to your graph. So this is what I want it to look like. So I'm going to trace to see just how many places that it crosses the x-axis in my interval. So I'm looking from 0 to 6.28. So I'm tracing and I'm hitting my right button. So there's 1, somewhere around 1.17, but we're going to get the exact. There's 2, somewhere around 2. Haven't hit another 0 yet. Still in my... There it is. So it only touches the x-axis twice in the interval from 0 to 6.28. So I've got to find out where those are. How do we figure that out? So we're going to do second trace. You get your calc menu, right? So you're going to go to your calc menu and you're going to find zeros. Right? So you're going to hit second trace, which is calc, which is 0, which is 2. So I want to get to the left of my first 0, so I'm getting all the way back over there. And I want to be, on this case, below, so hit enter, then go above, hit enter, and then guess. Notice that your y value should say 0. My x value is equal to 1.0 what? Does it stay at 8 or does it bump up to a 9? Look at what's next door. We've got a 5 next door. Doesn't that bump the 8 up to 9? So make sure you use proper rounding rules. So 1.09, and then do it again, second calc, 0. So I want to get to the right, which this time is above the x-axis, hit enter, and below, hit enter, and enter 13. Again, my y value is 0. This time I've got 2.0, is it 5 or 6? 6, so 2.06. So there are my two answers. Make sure that you only use your calculator where it says you can use your calculator. Then I want you to take out the sheets that I gave you in class. And I want you to look at 4 and 5, and I want you to now work those and see, based upon what we just did in examples 7 and 8, if you can do those problems now.